Thank you very much for taking the time to come over for the AMC Middle Primary 2018 past year paper go through. My name is Teacher Chi Yew from Think Academy, and I really thank you for being around to view this video. So in this case, in this video, we are going to go through the most difficult questions of the AMC paper. In this case, there will be questions 26 all the way to question 30. But not to worry, you guys are in my WhatsApp group and you guys encounter a little bit of difficulty in trying to solve question 1 to question 25, feel free to approach me as well in the WhatsApp group, and I will also be able to provide you with the necessary help and guidance. Now, without further ado, let us begin on the first question. In this case, it will be question 26. Now, for archers, are having some target practice, each with 2 arrows. Archery hits regions A and C for a total of 15. Billy hits regions A and B for a total of 26. Charlie hits regions B and C for a total of 13. If Davy hits region B twice, what will his score be? Now in this case over here, what I personally recommend for students attempting to do all these questions is to always highlight the very important key points in this question. So in this case over here, they have 2 arrows, and Archery has hit regions A and C for a total of 15 points. Billy hits regions A and B for a total of 18 points. Charlie hits regions B and C for a total of 13 points. Now in this case over here, we notice that Davy hits region B twice. What will his score be in this case? Well, in this case over here, what we can kind of tell is that all regions A, B, and C, alright, A, B, and C are likely to have different scores. That's something we can kind of tell in an archery competition setting. Well, in this case over here, let's take a look and try and write out how Archery, the equation that governs Archery's, Billy's, and Charlie's scores. So in this case, for Archery, let's take a look. We have A plus C equal to 15. Right? What about Billy? Billy in this case will be A plus B, which is equal to 18. And what about Charlie? Well, for Charlie itself, it will just be B plus C equal to 13. Well, it looks a little bit difficult, but what we are looking out for in this case would just be 2 B's, right? So if Davy hits region B twice, what will his score be in this case? Now, let's take a look a little bit more carefully. You notice that if I were to add Billy and Charlie up, I will actually get this. I actually get A plus 2B because they are going to use 4 arrows. 1 lands on A, 2 lands on B, and 1 lands on C. And what would the total score be? Well, it will just be a sum of Billy and Charlie's score, which will be 31 in this case. But hey, A plus C looks very, very familiar. We remember, Archery's score is just A plus C, which is equal to 15. If I were to take Billy and Charlie's score, subtract away Archery's score, right? So if I were to subtract, do a long subtraction over here, what will I obtain back at the end? I'm just going to get 2 arrows that hit B twice. And what will the score be in total? In this case, it's just going to be 31 minus 15, and I'll get a final answer of 16. So if Davy hits the region B twice, his score will just be 16. Alright, so I hope many of you guys can do this in a more efficient method over here. In this case, through a process of elimination, writing down equations that govern the particular score that a particular player has obtained. And then from there, we'll try to infer and look out for a pattern with our goal in mind. In our mind right now, our goal is to try and obtain what is 2b. And through this thought process, we are able to obtain what is 2b through taking Billy plus Charlie minus away Aries score. Alright, so hopefully this is good. Everyone understands how to work on these kind of questions. Now, let's move on to question 27. Well, in this case, question 27 looks something like this. A teacher wants the students to guess the 3-digit number that she's thinking. She gives 2 clues in this case. Firstly, it is divisible by both 11 and 3. If you subtract 1, the result is divisible by both 2 and 7. What is this particular number? Now, let's take a look at this question in this case over here. Now, if something is divisible by both 3 and 11, it must also be divisible by 33. If I were to subtract 1, the result is divisible by both 2 and 7. And if the number is divisible by both 2 and 7, we can kind of tell that it must also be divisible by 14. That's the key idea behind solving this question over here. Now, let's take a look at this. The number itself must be a multiple of 33. But after I subtract 1, it must be divisible by 14. In this case over here, let's take a look at the difference between 33 and 14. Well, when I were to divide 33, if I were to divide 33 by 14, I actually get a 2 remainder of 5. But I do not wish to have a remainder of 5 in this case. I would like to have a remainder of 1 because afterwards, when I actually obtain a remainder of 1, I will actually be able to subtract 1 and the result itself will be divisible by 14. So in this case over here, following our idea, we'll multiply by 3 because 5 times 3 gives us 15, and then 15 divided by 14 gives us 1 remainder 1 in this case, and hence we are going to multiply by 3 on both sides. So what about 33 times 3 divided by 14? We are just going to obtain 7 remainder 1. So 99 might be the answer. But hey, there's a problem. 99 is not a 3-digit number. 99 is just a 2-digit number in this case. And hence, we need to do something about it. In this case over here, what we have to do is to try and do the idea of rotation. Well, we are going to multiply by another round of 33 times 14 in order to obtain our final answer. In this case, 33 times 14 plus 99 is going to give us 462 plus 99, which will end up with 561 as our final answer in this case. So with that, we will also like to make sure that we can do a little bit of check. So hopefully you guys will do a little bit of check first and check whether the number 561 is divisible by both 3 and 11. On top of that, if I were to subtract 1, in this case, the result must also be divisible by both 2 and 7. In this case, 560. Alright, so I'll leave that to you. And hopefully you guys can give it a check. And hopefully you guys understand a little bit more about the concept of number theory and divisibility rules. Alright, so with that, let me move on to the next question over here. Now, what's the next question? These staircases are made from layers of blocks. Each staircase is 1 block wider, 1 block longer, and 1 block taller than the previous staircase. How many blocks are needed to build the 12-step staircase? Now in this case over here, it looks like a pattern question, and hence there must be patterns going around over here in this case. So how does this pattern look like? Well, let's start with a little bit of notation over here. So Tn will represent the nth pattern. Alright, number of blocks in the n pattern. Number of blocks in the nth pattern. Now, in this case, we can take a look at a little bit of pattern over here. Now, let's take a look at T1. Let's start simple. T1. T1 itself will just be 1 because there's literally just 1 block over here. Now we notice next over here. For 2 steps, there is actually 2. In fact, there is actually 1 block wider, 1 block longer, and 1 block taller. Now we notice that T2 will just be 6. Now, what's next? We notice that T3 becomes even larger right now. T3 in fact has 18 blocks. But it doesn't look like a pattern at all over here. It doesn't really look like a pattern. And definitely if we are going to try to find the 12-step staircase by imagining, it's going to be extremely difficult. And the pattern is not clear. Pattern is not clear over here. So what do? We'll try and break it down a little bit more further. We'll try to break it down a little bit further over here. So in this case over here, let's take a look at T1 again. Well, yes, it's just 1 block. But what about 6? What about 2 blocks, 2 steps in this case, the second pattern? Well, we do know that it actually starts with a 2. But it consists of 1 plus 2 rows of 2 blocks each. So we can consider writing it as 1 plus 2 here. In the same fashion, we notice that for T3, it goes in the same pattern as well. It's just 3 times 1 plus 2 plus 3. Right, because now all of them, each row has 3 blocks, and we have 1 plus 2 plus 3 rows in total. So now it becomes very easy. What about T12 now? So it becomes very easy to figure out what is T12, right? T12, following the pattern, is just going to be 12 times 1 plus 2 plus 3 plus 4 all the way to plus 12. And that's where your Gaussian sum is going to come in. Well, remember, when we have 1 plus 2 all the way to plus n, it's just going to be n times n plus 1 divided by 2. Right, so we are going to apply this formula. We are going to have 12 times 12 times 13 over 2. And hence, the final answer, after a little bit more of calculation, we're going to end up with 936. So, there 936 blocks are required in order to build the 12-step staircase. I hope everyone is able to see this a little bit more clearly, that patterns are not always what it seems. We'll try to break it down as much as possible in order to try and see a pattern. If we are to just stare at these 3 numbers over here, 1, 6, and 18, it's going to be very difficult. But by being able to recognize that there's a little bit of geometric pattern that's going on over here in these 3 steps, we are able to break them down into much more simpler concepts over here. And this is the key goal of this question. Alright, now, without further ado, let's move on to the next question over here. In the algorithm below, the letters A, B, and C represent different digits from 0 to 9. What is the 3-digit number A, B, C? Well, in this case over here, it does not look particularly easy. So let's try to write out another copy of it and try to infer one by one over here. So let Teacher Chi write out the pattern that Teacher Chi can edit. Alright, we need to form a 2018 over here. Now, clearly we can see that in the hundreds place, let's carry forward a 1 to a thousands place because the final value is actually a 2 from a 1. So there must actually be a carry forward over here. So in this case, it makes sense for us to try and guess a number as large as possible. In this case, we'll try and guess a number such as A is equal to 9. A is equal to 9. And let us just change the values over here to 9. Now, with A equal to 9, now we can see that in the ones place, there must definitely be a carry forward of at least a 1 in this case, because we are moving from 9 plus B plus C plus 0 ending with a 8. There must definitely be at least a carry forward of 1. So in this case over here, we more likely than not we have a carry forward 1. So it makes sense for us to believe that B must be equal to 1 as well, so that in the tens place we can actually get a 1. Right, so by doing this, we can actually get a 1 over here. And we are almost there. In this case, we have, in the ones place, 9 plus 1 plus C plus 0 equal to 8. Well, what number could it be? Well, naturally, the last number that we are looking at over here would just immediately be 8, because 9 plus 1 plus 8 plus 0 is going to be 18, which satisfies our criteria. We require a carry forward 1 and end off with an 8. Well, that's pretty much about it. So in this case over here, always remember to answer the answer the question. What we are looking out for is a 3-digit number A, B, C. In this case over here, the 3-digit number will just be 918. Right, so this cryptarithmetic puzzle is a little bit more difficult, but I hope everyone is able to understand and start off make a logical guess using reasoning and understand what is carry forward about in order to better appreciate these problems. Alright, so let us move on to the last question for the day. Now I wrote the counting numbers joined together in this form. So some of you guys might be asking, what are counting numbers? Well, counting numbers are really just natural numbers. 1, 2, 3, and so on and so on. 4, 5, 6, 7, 8, 9, 10, etc. So now in this case, they are all joined together in this example over here. So we have a really long list of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10, alright? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc, etc. Now, which of the counting numbers was I writing when the 100th zero was written? So what do they mean by that? Well, in this case over here, we have a lot of zeros in these numbers, right? And what is the first zero in this case? Well, the first zero will belong to 10. So the counting number itself would just be 10. And our goal is to try to find the 100th zero. Looks really difficult, but not to worry. Teacher Chi will go through this with you slowly over here. Now, in this case over here, we can try and break down this problem into a little bit more simpler problem over here. We can consider things like, for example, 1-digit numbers, 2-digit numbers, and 3-digit numbers, and so on and so forth, in order to try to find the 100th zero. Because it's extremely difficult for us to immediately try and find the 100th zero, be it through writing or listing out the numbers, because it's going to be very tedious and difficult. So breaking them up into based on the number of digits they have might seem like a more appropriate idea. So let's start off using this idea over here. So let's take a look at the first 9 digits, right, which is 1 to 9. How many zeros are there in this case? Well, unfortunately, there are 0 zeros because they are just 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are not going to be any zeros. But now, let's move on. What about 10 to 99? How many zeros have we completed so far? Well, we have 10, 20, 30, 40, 50, all the way to 90. In this case over here, there are going to be just 9 zeros. In this case. And then afterwards, we'll move on to 100 to 999. Which is a little bit difficult, right? 100 to all the way to 999 is going to be very difficult for us to count the number of zeros because it's very big. But hey, we can break it up into little chunks as well. Maybe we can start small. We can look at 100 all the way to 199. Because chances are, the number of zeros from 100 all the way to 199 is going to be the same as the number of zeros from 200 to 299, 300 to 399, and so on and so forth. So it makes sense for us to try and look out for 100 to 199. Well, we can break it up in the same fashion as what I did over here. In this case, let us break it down in this bottom left corner. 100 itself, it has 2 zeros. It's a little bit odd one out over here. Next one, we can consider the first digits. 101 to 109. In this case, there are 9 zeros. What's next? We can consider 110 all the way to 199. How many zeros are there? In this case, there are 9 zeros as well because it's from 110, 120, 130, etc. all the way to 190. Well, in total, how many zeros do we have over here? Well, for 100 all the way to 199, we have a grand total of 2 plus 9 equal to 20 zeros. And voila, we get a very nice pattern over here. So this one will also tell us that 200 to 299 by the same argument is going to have 20 zeros. 300 to 399 is going to have 20 zeros as well. So on and so forth. Now, we are going to try to get the numbers such that it's as close to the 100 zero as much as possible. In this case over here, it makes sense for us to do 100 to 499. Because this one will constitute 20 times 4, which will give us 80 zeros. And what's the last step over here? We have 89 zeros so far. We are left with 11 zeros. Well, if we have just 11 zeros, it will be pretty fast. It will just do a little bit of listing over here. We can do 500, 501, 502, 503, and so on. And then we will notice something by the time we reach the 11 zero. The 11 zero will belong to 509, which is the 100 zero that we are looking for. Well, of course, there is a much easier way. We can actually look out for 500, which is 2 zeros, and we need 9 more zeros. From 501 to 509, there are 9 zeros as well. So the same argument applies. But of course, if we have 11 zeros over here and we have a lot of zeros from 500 onwards, we can also do this trick as well. But the final answer is going to be the same. The counting number is going to be 509. Well, so we have come to the end. We have come to the end of the go through AMC Middle Primary 2018 past year paper go through for questions 26 to 30. Really appreciate your time and effort taken to come and watch this video and try out the paper. But not to worry, if you guys are not sure on how to attempt any questions from question 1 all the way to question 25, you can always contact me via my through the WhatsApp group, and Teacher Chi Yew will be able to assist you and provide you with advice on how to work on those questions. Now with that, have a good day and I'll see you around. Keep a lookout for the next set of exam papers that are coming up. Alright, with that, I will see you around and goodbye.